Okay, so in this video, we have been talking a lot about how to make fractions and talking about parts and wholes. So we are finally transitioning now into operations with fractions, so adding, subtracting, multiplying, and dividing. So we are going to be doing that by drawing pictures. So today I am starting on page 186. So we're going to start by talking about adding and subtracting fractions. So drawing pictures to represent. Okay, so number one says Maggie had 1/5 of a box of crayons. Mark had 3/5 of a box of crayons the same size as Maggie's. So if they put all their crayons in the same box, how much of a box of crayons did that make? Okay, then over here we have kind of the step-by-step process in order to draw a picture to solve these problems. So it says draw 3 5x2 units. So 1, 2, 3, 4, 5. So 5x2, 5x2, and 5x2. All right, since addition means 2, what does addition mean? So previously when we talk about word problem types, we have join problems. So since addition means to join things together, we are going to draw the combined amount in the third unit. So I skipped the rest of part A. So draw 5x2. So sorry, draw 3 5x2 units. So in the first unit, model 1/5. So that would be what Maggie had. I was jumping ahead of myself. I'm sorry. Okay, so if Maggie has 1/5, you would want to split this into 5 equal parts. So 1, 2, 3, 4, 5, and show 1/5 of them. And then in the second unit, we want to model Mark's amount, which is 3/5. So again, 5 equal parts, and Mark has 3 of those parts. So then step B, since addition means to join, draw the combined amount in the third unit. So third unit is also split into 3 parts. So if we take Maggie's 1 piece and Mark's 3 pieces to combine them all together, we have a grand total of 4/5. So it says complete the number sentence, write the units with each fraction. So we have 1/5 of a box. So this is what I mean by units. So we have 1/5 of a box of crayons added to 3/5 of a box of crayons, and we end up with 4/5 colored in. So 4/5 of a box. So a box, and a box. Okay, let's check out number 2. So number 2 says Mr. and Mrs. Toll had twin bags of M&Ms, but they each decided to eat some. Mr. Toll had half of a bag of M&Ms left, and Mrs. Toll had 1/3 of a bag of M&Ms left. So if they join their bags, how much of a whole bag was left? Okay, so this one says start by drawing 3 4x3 units. So here's one 4x3. Here's another 4x3. And here's another 4x3. All right, then it says model 1/2 in the first unit. So this would be Mr. Toll's bag. So we want to split this into 2 equal parts. And he has half of a bag. So that's going to look something like this. And then Mrs. Toll, modeling 1/3 of the second unit in a different color. So Mrs. Toll, she has thirds, so we need to split this into 3 equal parts. So she has this amount. All right, and then it says redraw each of those in the third unit. So we have a small problem because we have this size piece and this size piece. So when we go to add things together, we need same sized pieces. So that wasn't a problem up here with number 1 because we had 5ths and 5ths, and the answer was in terms of 5ths. Here, now we have a 1/2 and a 1/3, and we can't add those together because they're the same size, or they're not the same size. So it is important to change each unit into the same size pieces. So that means you will break halves and thirds into what? So what can I chop this into and chop this into so that we do have same size pieces? So we should be splitting them into sixths. Okay. So 1/2 is going to change into, so I have it cut in half, so then if I also cut it into thirds like Mrs. Toll's bag is, you will now see that we have 3 pieces out of 6 pieces total. So 1/2 becomes 3/6. And then 1/3, to make it look like Mr. Toll's, if we cut it directly in half like his bag was, you can see Mrs. Toll now has 2 of 6 pieces. So 1/3 is 2/6. So now we know when we model our full bag over here, we want to also split it into sixths. So what's our answer? So 3 pieces for Mr. Toll and 2 for Mrs. Toll. So our answer, there are 5 pieces shaded out of 6 pieces total. So that says, write the complete number sentence showing original fractions, the new fractions, and label with units. So what did we start with? We started with 1/2 of a bag of M&Ms being added to 1/3 of a bag of M&Ms. And again, we can't just add halves and thirds together. We need same size pieces. So sometimes in math, maybe you've heard this called common denominators. I prefer to think of same size pieces because it always reminds you that what you are adding together, not necessarily just common denominator. That's just like a number. And so if you're working with students, you want to make sure that they can understand this concept of same size pieces and not just, oh, this is a number that like 6. Okay, so it's where is the 6 coming from in the picture. So 1/2 we converted into, that's equivalent to 3/6 of a bag. And then 1/3 would be 2/6 of a bag. And so then based on our picture, the final answer is 5/6 of a bag. Okay, so there is 1 and 2. All right, let's look at the next page. Now it's challenging you to write a word problem that could be solved using 2/5 and 1/3. So go back to thinking about the types of word problems we had. We have like join problems. So think about the structure of join problems. So somebody has to have 2/5 of something, and then we're combining it with 1/3 of something else. So let's just say we have, what can we have? So maybe Stacy has 2/5. What do we want her to have? How about a bag of apples since it's the fall? So Stacy has 2/5 of a bag of apples. So whatever you want it to be if you write your own word problem. And then, I don't know, how about Mark has 1/3 of a bag of apples. So then the question would be, how much do they have total? Okay. All right, so this one is telling us to draw 3 5x3 units. And this is the one where I did not give you enough dots, so I apologize. So 5 would be 1, 2, 3, 4, 5. You need this like extra row up here. So it's going to be a little taller than the dots I gave you. So sorry. Okay. So then model 2/5 in one unit, 1/3 in the other unit, and then join the fractions in the third. So 2/5. So we would want 2 parts there. And then 1/3 is going to be like this. All right, and then Again, in order to add same size pieces, we need to make them into same size pieces. So if I take this first one and also split it into thirds, and then take the second one and split it into fifths, then now we have equal sized pieces, which are 15ths. So let's see if we combine. So there's 6 of them here. And then five of them here. So that is a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 15ths. Okay, so show the complete number sentence with units. So we started with 2/5 of a bag of apples plus 1/3 of a bag of apples. And that is equal to 2/5 and changed into 6/15. And 1/3 changed into 5/15. So that is a total of 11/15. Okay, so 11/15 for that one. All right, and then number 4. 4 6x3 units have been shown. So write a word problem for 2/3 plus 4/5. The answer to, that should say to this problem, will be greater than 1. So be sure your problem will make sense for your solution. Okay, so let's write ourselves a word problem. So 2/3 plus 4/9. So let's see, let me use some names of some people in class. We have 2 Tyras in class and 2 Chloes in class. So let's say maybe Tyra, oh, and then I totally spell it wrong. So let me try that again. Tyra, let's say runs 2/3 of a mile. And then let's say Chloe runs 4/9 of a mile. So how much did they run, or how far did they run total? All right, so we would want to model the first one, so 2/3. So 2/3 is going to look something like this. Split it into 3 parts, take 2 of them. And then 4/9, we need to split this into 9 equal parts. So if we do thirds and thirds, so there's 9 equal parts, so 4 of them, it's going to look something like that. All right, then we need equal size pieces. So if we split this one also into 9, so cut it again into thirds, now we have same size pieces. So we do that over here. So what ends up happening, which I already said, it's greater than 1. But if we try and fill this in, so there's the 6. And then we need 4 greens, but 3 of them fill up the hole. So that's why we need the second rectangle. All right, so then our answer should be 1 and 1/9. Okay, so I believe this continues on to the next page. So let's see. So we modeled 2/3 in the first unit, 4/9 in the second unit. You will join the 2 fractions, so write the complete number sentence. So again, let's see, it was 2/3 of a mile plus 4/9 of a mile is equal to, we converted 2/3 again into 6/9 plus the 4/9, which ends up, and again this is mile, which ends up being 10/9. So we have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and it takes 9 pieces to make the whole. Or you could say this is 1 full mile plus 1/9 of another mile. So 1 1/9 miles. Okay. All right, so that is addition. So moving on to subtraction. All right, so if you remember again from our word problem types, there are two different ways that we can think about subtraction. So the one that we have been using so far mostly is takeaway. Okay, so we use takeaway if you remember when we did our base block drawings. So we drew like the flats, the longs, and the units, and then we took away certain pieces. The second way that we could do subtraction, which I believe I mentioned and yet we didn't do it yet, would be comparison. So we did talk about comparison word problem types. So that would be something like, let's just use Tyra and Chloe since they're on my mind. So like Tyra has 10 apples, Chloe has 20 apples. How many more does Chloe have than Tyra? That would be a comparison. So we have done some comparison subtraction before when we talked about word problem types. So when we are drawing pictures, it is usually easier in fractions to model with comparison. So this is where we're going to talk about comparison instead of takeaway, like we've always done before. Okay, so let's look at these examples. So number 1. Brandon has used half of a gallon of gas to mow his yard, and Ashley used 1/3 of a gallon of gas to mow her yard. So how much more gas did Brandon use? Okay, so if we're doing a comparison, this time it says just draw 2 3x2 units. Okay, so model 1/2 in the first unit, so this is going to be Brandon. So 1/2 would be, let's see, I always use orange first, right? So there's how much gas he used. And then Ashley would be 1/3. So 1/3 would be this much. Okay, then it says, now redraw the 1/3 directly on top of the 1/2 and see how much more space the 1/2 shows. How many individual squares is this? So again, it would be nice in order to compare these if we made them same size pieces. So if I took Brandon's and cut it into thirds like Ashley's is, and then if I took Ashley's and cut it in half like Brandon's is, we would have equal size pieces. So what they want you to do is take Ashley's 2 green, put them directly on top of Brandon's pieces, and then you should see how much more does Brandon still have. He's got 1 piece out of the 6 it takes to form 1 full gallon of gas. So how many individual squares of 1/2 is it showing? So that's 2 squares. So that goes here. And since the 1 square is 1 square out of 6, what fraction is shown by the difference that you see? It's the 1 out of the 6. So this is why it's 1/6. Okay, so writing the number sentence. So 1/2 minus 1/3, what did we actually do? So we got this common denominator or same size pieces. So we made 1/2 into 3/6, and then we made 1/3 into 2/6. So 3 pieces taking away 2 pieces, or comparing, there is 1 extra piece out of the 6. And then the unit, we're talking about gallons of gas. So this would be 1/6 of a gallon. All right, so that's number 1. Okay, how about number 2? So Jason rode his bike 2/3 of a mile to class today, and Jamie rode her bike 1/6 of a mile to the store. So how much greater distance did Jason ride his bike? So draw 2 4x3 units. Okay, so one's for Jason, one's for Jamie. Jason, Jamie. All right, so start by modeling 2/3 for Jason. So Jason will look something like this. And then Jamie is 1/6. So 6 equal parts, and she has one of them. All right, and then redraw the 1/6 into the first unit and determine how much bigger it is. Well, again, we want to be able to compare same size pieces. So this is much smaller than these pieces. So if I take Jason and cut his pieces in half, then we have 6ths and 6ths. So if Jamie takes up one of those, how much bigger is 2/3 than 1/6? It's these 3 pieces here out of 6 pieces in the whole rectangle. So our answer should be 3/6, which is 1/2. So express the number sentence. So we have 2/3 of a mile minus or compared to 1/6 of a mile. And let's see, we changed 2/3 into 4/6. And 1/6 stayed the same. So that leaves us with 3 pieces, so 3 out of the 6, which if you want, you can reduce that down to be 1/2 of a mile. All right, number 3. Now we have a chance to write our own word problem. So try this and use a comparison. So somebody has 1/2 of something, somebody has 2/7 of something. So how much bigger is the 1/2 than the 2/7? So, okay, so let me see. I was looking at my class list again. So how about Camille and Mary this time? So some more of you. So let's say Camille has, oh, I don't know, 1/2 of, we'll just make something simple like a candy bar. I'm not very creative, so sorry. So Camille has 1/2 of a candy bar left. And then I said Mary. Mary has 2/7 of a candy bar left. So how much more does Camille have than Mary? Okay, so who has the bigger piece and by how much? All right, so this time, I've always told you how big to make your rectangles. So this time it says choose an appropriate unit and model it twice. So we need to be able to draw a rectangle that can be split into 2 equal size pieces as well as 7 equal size pieces at the same time. So my suggestion is to make a rectangle that is going to be 7 by 2. So 1, 2, 3, 4, 5, 6, 7 by 2. So if it's 7 by 2, we can split it 7s horizontally, or we can split it in half vertically. So if we do 2 of these, let's see, first one is Camille. So cut her candy bar in half. So something like this. So wouldn't it be weird if you actually had a candy bar like this and then you just ate like this half of it instead of like eating it downward like that? Maybe if it was like a Kit Kat or something. This is Kit Kat style candy bars. Then what about 7ths for Mary? So Mary is 2/7. Okay. And then redraw the 2/7 over here on Camille's candy bar to see how much extra she has. So again, we need same size pieces. So if I take Camille's and split it into 7ths like Mary's, and then take Mary's and cut it in half like Camille's, then Mary has 4 pieces and Camille has 1, 2, 3, 4, 5, 6, 7. So if we cover up 4 of them, Camille still has 3 extra pieces of a candy bar that is now chopped into 14 pieces. Okay, so let me check really quickly. Is this on the back? This is not on the back. Okay. So, oh, I just didn't read my instructions. Write the complete number sentence for this problem. So what did we do? We had half of a candy bar, and we were comparing it to 2/7 of a candy bar. And then we converted them to same size pieces. So Camille's was now 7/14. And Mary's was now 4/14. And then that equals, if we compare, you had 3 extra pieces out of the 14 total in the candy bar. So 1/2 minus 2/7 is 3/14. Okay, let's flip this over and see. We're writing word problems for fraction subtraction using the separate meaning. Okay, so yeah, so what about the other one? So separate meaning take away. So all of the ones we have done so far represent comparison. So what if we tried it with takeaway? So it's just saying, first of all, sketch a model that would show 2/3 minus 1/3 using the separate model. So a separate model would look like this. So you would start with 2/3. It's kind of boring. So you would start with 2/3, and then you take away 1/3. So if you take that piece away, you are left with one of 3 pieces. So 2/3 minus 1/3 is 1/3. Okay. So then it says, which of these word problems would be drawn with the model shown above? So a lot of students get multiplication and subtraction confused. So this is a little introduction to that. So this says Jerry had 2/3 of a sub sandwich and then gave 1/3 of it to his girlfriend. How much did he have left? So the question is A, is this truly 2/3 minus 1/3, or is something else going on? So think about a picture of what this would look like. If Jerry had 2/3 of a sub sandwich, so he had this much. So he only had this orange part. Then he is going to give 1/3 of it to his girlfriend. So what does that mean? He's going to chop this into 3 parts, his sandwich into 3 parts, and he is going to give his girlfriend 1/3. All right, so does that look like what the picture is up here? So hopefully you said no. So what is happening in A is actually multiplication. He is doing 1/3 of, which means multiply, 2/3. Okay, so A is actually multiplication. B, if Carrie had 2/3 of a gallon of milk and used 1/3 of a gallon for breakfast, how much did he have left? So is that really 2/3 minus 1/3? So let's draw a picture. So if Carrie had 2/3 of a gallon of milk, and then he used 1/3 of a gallon of milk for breakfast, so he's using that part for breakfast. So what does he have left? 1/3. So B is an example of 2/3 minus 1/3. Okay. All right, how about the next one? Sam had 2/3 of his homework complete. He did 1/3 of it before he played basketball. So how much of his homework was done before he played basketball? So again, if we want to draw a picture of what's happening, Sam had 2/3 of his homework done. Oh, sorry, he has 2/3 still to do. Okay, so that's the portion he still has to do. Then he did 1/3 of it before he played. So that means the homework that he has would be split into 3 pieces, and he is going to do one of those 3 pieces. So again, does this look like this? No. So again, this would be an example of multiplication. So here we are doing 1/3 of the 2/3 of homework we still need to do. Okay. And then Jenny had 2/3. Oh, this one doesn't make any sense. So Jenny had 2/3, let's say, of an hour. to work out. She used 1/3 of an hour to run, so how much of her workout time was left? Okay, so if she had 2/3 of an hour and she used 1/3 of the full hour, which would be this part, how much of her workout time was left? So this indeed is 2/3 minus 1/3. Okay, so the big idea here is that you should notice when we were doing all of our other problems that the labels are always going to match. So if we look back a few pages, let's see, help if I started at the beginning. So you should notice with addition, we have a part of a box, a part of a box, a part of a box is the answer. We had a part of a bag, and a part of a bag is the answer. Let's see. Then we had a part of a bag, a part of a bag is the answer. Let's see here. I'm missing a page. Oh, because it's on the back of this one. Duh. Okay, so a part of a mile and a part of a mile has a part of a mile answer. And then finally, a part of a candy bar, a part of a candy bar, and a part of a candy bar. So it's always a part of a whole, a part of a whole, and a part of a whole when we are talking about addition and subtraction. So what is happening with multiplication, which we're going to talk about in a couple of videos in the future, is that with multiplication, you are taking a part of another part. So a part of a fraction of another fraction. So a fraction of a fraction. So instead of a fraction of a whole thing and a fraction of a whole thing, like we're doing up here. So a fraction of a whole and a fraction of a whole gives you a fraction of a whole. This is a fraction of a fraction. So that is the big difference between subtraction and multiplication. And then finally, to round off this page, page 190, writing word problems using separate or take away. So these are all going to be pretty much identical to one another. So I don't want to spend like a whole lot of time talking about this necessarily, but let's just say we want the labels to match. That's the most important thing. So let's say for the first one, 3/4 minus 1/2. So maybe I have 3/4 of a pie, and then I eat 1/5. You want to say of a pie. So you want the labels to match. It's a fraction of a whole thing and fraction of a whole thing. So how much pie do I have left? That would be the answer to the question. Okay, so if I had said something like I have 3/4 of a pie and I eat 1/5 of it, it implies 1/5 of the thing I have, which is another fraction, not a whole thing. So if I said 1/5 of it, that would be 1/5 times 3/4. And again, we're going to talk more about this later if this doesn't fully make sense right now. That is okay. How about 1/2 minus 6/7? It's telling me, by the way, not to solve. Oh, I guess, but it says write the complete number sentence and label the answer. Okay, so maybe I should do that. So we have 3/4 of a pie minus 1/5 of a pie. So if we had same size pieces, we would have 20ths. So that would be 15 20ths. Taking away 4 20ths. So our answer would be 4 pieces from 15 pieces would be 11 pieces. So 11 20ths should be the answer for that one. Okay, so back to number 2. 1/2 minus 6/7. So I have 1/2 bags of candy. I eat 6/7, again, matching labels of a bag. So how much candy is left over? All right, so 1/2 bags minus 6/7 of a bag would be what? So common denominator, or same size pieces, would be 14ths. So we would have 1 and, let's see, that would be 7/14. And then this would be 12/14. So 1 and 7/14 minus 12/14. So I'm going to have to dip into my full bag, right? So one full bag would also be 14/14. So 14/14 plus 7/14, we would actually have 21/14, taking away 12/14. And then what, that would be 9/14 of a bag of candy would be our answer. Okay. All right, and then finally, 5 2/7 minus 3 3/4. So I'm going to write one of my favorite word problems a student ever wrote me before. So I have, maybe you can relate. I have 5 2/7 hours until my homework is due. My homework will take 3 3/4 hours. So the question would be, how long can I still procrastinate? You've never done any of that before, right? So one of my favorite word problems ever written by a student before. All right, so we have 5 2/7 hours, and we're taking away the 3 3/4 hours it would take. So all of the time remaining, we can still be wasting not doing our homework. Let's see. So we have 7ths and 4ths, so same size pieces would be 28ths. So let's just see. Let's leave 5 and 3 how they are right now. So let's see, 28ths would be 8 28ths. And then 3/4 would be, what, 21 28ths. Okay, so we have to take away 21 28ths. So we do need one of our hours to be split back down into 28ths. So this would become 4, and let's see, that would be 28 28ths plus 8. So 36 28ths minus 3 and 21 28ths. So do we have 1 full hour, and then what, 15 28ths of a second hour? So our answer should be 1 and 15 28ths hours. All right, so this video is pretty long, so I'm going to stop right here, and then I'm going to make another video talking about what it would look like with our manipulative. So adding and subtracting using our Cuisenaire rods. So stay tuned for that video.